Hello. In this video, we're going to discuss rates of change. And before we get into the very calculus-y part of this video, talking about instantaneous rates of change, we're going to focus in here on average rates of change. And an average rate of change should be, to all of you guys, relative review. Essentially, what we know about average rate of change is that average rate of change simply means slope. That means we're going to take 2 points and we are going to find the angle, in a sense, the incline or the decline between those 2 points. In this case, we'd have a positive rate of change. If my 2 points fell from left to right, we might have a negative rate of change. So let's think about or recall what we know about slope. Generally, we use the variable m to represent slope. And what we say for slope is that slope is rise over run, or change in the y values over change in the x values. So change in y over change in x, that delta, that triangle means delta, or reads as change in. So change in y over change in x versus rise over run. Now, mathematically, we might write that, if we were given 2 points, we would say y2 minus y1 over x2 minus x1. If we wanted to use function notation for our y values, we might write this as f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1. So it's still change in y over change in x. So if you notice, the definition in our book writes it f of b minus f of a. Then we've got b minus a. So we're looking at some average rate of change. And again, keyword average means we're dealing with a straight line for any function. So if we want to find the average rate of change for a function with respect to x, x being the variable in the denominator with respect to, we're looking as x changes from some initial point A to a terminal point B, or rather x is on the interval from A to B. So x is in between these two A and B values. And in order to find average rate of change, if you see a word problem, anything that tells you to find average rate of change, really, you're just applying your slope definition. Visually, what does that mean? Slope is the change in y over the change in x. In this picture, this graph we see here, the y value is distance, s of t, position, over change in time, t. So we've got t on the x-axis representing time, and s of t on our y-axis. S of t represents the position, or the change in the distance. So distance, the y change over the horizontal change, that gives us the average speed. So if you look at between, say, these 2 points, right here we'll call that A, and this second point B, we can calculate the change in y, that vertical distance, 25 miles, over the change in x, this horizontal distance is 0.5, and 25 over 0.5, the change in y over the change in x, that gives us 50 miles per hour. And thinking about the units there, we have miles in the numerator, hours in the denominator. You see that rate is miles per hour. So let's just look at one average rate of change example. For this example, we're going to find the average rate of change for this function, y equals the square root of the quantity 3x minus 2 from x equals 1 to x equals 2. Now, x equals 1 is our starting or our initial point, so that's my a value. X equals 2 is my terminal point, that's my b value. In a sense, we're thinking about this as an interval from x equals 1 to 2. So by our definition, if we go back over here to the first page, by our definition, we know it's going to be f of b minus f of a over b minus a. In this situation, f of b, that's f of 2, minus f of a is 1, all divided by b minus a, or 2 minus 1. So f of 2, I can plug 2 into my function. I've got the square root of 3 times 2 minus 2 minus the square root. I'm going to plug 1 in. 3 times 1 minus 2, all divided by this value I have in the denominator here. 2 minus 1 is 1. So essentially that denominator is going to go away because dividing by 1 doesn't change anything. So I'll just solve each of these calculations. The square root of the quantity 3 times 2. 3 times 2 is 6 minus 2. That's the square root of 4. Minus 3 times 1 is 3. Take away 2. We have the square root of 1. Or rather, the square root of 4 is 2. And the square root of 1 is 1. So 2 minus 1 equals 1. And so thinking about what we did just there, or if we were to draw this graph, we would get a curve that looks roughly like this. That x-intercept value is going to be at 2/3, 0. And so we have these ordered pairs on our graph. If I plug in 2, I get out 2. If I plug in 1, I get out 1. So I've got this point 1, 1 on the graph. I also have this point 2, 2 on the graph. And what we found is not the exact rate of the curvature. We found the average curvature, or what we might call the slope of the secant line. So the secant line connects those 2 points. And so the slope of the secant line is 1. And that should make sense. If you were to draw a line on your paper from the ordered pair 1, 1 to the ordered pair 2, 2, you would get a perfectly 45-degree angle that connects those two, which is a slope rise over run. We went forward 1 and we went up 1. So we rise 1 and we run 1. So I hope you have a good understanding of average rate of change, because now we're going to talk about an instantaneous rate of change, or rather an instantaneous velocity, an instantaneous speed, if you will. As always, please feel free to email me if you have any questions or concerns.